The use of brain data or neurotechnology to manipulate or harm individuals raises significant ethical and privacy concerns. While the widespread misuse of brain data is not yet a reality, it's important to consider potential risks and how they could manifest in the future. Privacy invasion. Brain data, such as electroencephalogram, EEG, or functional magnetic resonance imaging, fMRI, scans, can reveal highly personal information about an individual's thoughts, emotions, and cognitive abilities. Unauthorized access or sharing of this data could lead to a severe invasion of privacy. Manipulation. Brain-computer interfaces, BCIs, can be used to control external devices or even manipulate thoughts and behaviors. Malicious actors could potentially hijack BCIs to manipulate individuals, making them perform actions against their will. Mind reading. Advanced neuroimaging techniques may allow for the decoding of thoughts and mental states. Unauthorized access to this information could lead to mind reading without consent, which has implications for personal autonomy and privacy. Surveillance. Brain data collected through neurotechnologies could be used for covert surveillance purposes. Governments or other entities might use this data to monitor the mental states and emotions of individuals without their knowledge or consent. Data theft. Just as with any other personal data, brain data is susceptible to theft. Hackers could gain access to neurotechnology devices and steal sensitive brain data, potentially using it for identity theft or other malicious purposes. Neurosecurity risks. Brain-computer interfaces and other neurotechnologies may be vulnerable to hacking or cyberattacks, posing risks to users' safety and privacy. If these devices are not adequately secured, they could be exploited by malicious actors. Discrimination. Brain data could be used to discriminate against individuals in various contexts, such as employment or insurance. Employers or insurers might use this data to assess an individual's cognitive abilities or mental health status, potentially leading to unfair treatment. Coercion and manipulation. Brain data could be used to manipulate or coerce individuals by threatening to reveal their private thoughts or emotions. This could be especially concerning in situations involving vulnerable populations. Ethical dilemmas. The use of brain data in legal and ethical contexts could pose dilemmas. For example, in criminal cases, brain data might be used to determine guilt or innocence, but this raises questions about the reliability and fairness of such evidence. Long-term consequences. The long-term effects of exposure to neurotechnologies and the potential consequences of prolonged brain data collection are still not fully understood. There may be unforeseen health risks or psychological consequences associated with the use of these technologies. To mitigate these risks, it's crucial to establish clear ethical guidelines and legal frameworks for the collection, storage, and use of brain data. Individuals should have control over their own neurodata and the ability to give informed consent for its use. Additionally, robust cybersecurity measures must be in place to protect neurotechnology devices from unauthorized access and data breaches. Public awareness and debate surrounding the ethical implications of brain data are also essential to ensure responsible and ethical use of these technologies.